Hello! So I wanted to make a little video about a logic machine. Now this logic machine is based on designs by Martin Gardner in his book Logic Machines and Diagrams, and it's just a very simple way of looking at premises and seeing what is consistent with those premises. Now it's kind of interesting but limited in a number of ways, which I'll mention maybe towards the end of the video. Okay, so how does the logic machine work? Well, as you can see here, the logic machine is made up of these triangles, and within the triangles we have this grid of hexagons. And you can see that this is kind of the base triangle, as it were, the base kind of sheet for the diagram for the logic machine. And you can see that it has three propositional variables. I've used A, B, and C here for the propositional variables. So this machine can only deal with arguments with three propositional variables. You could make machines that would deal with more propositional variables, but they would be much more complicated. And this base triangle looks a bit like the truth table for a truth table with three propositional variables, because as you can see, you have every combination of A, B, and C, not A, not B, and not C. That is, these different 8 combinations. And rather like a truth table for three propositional variables, which has 8 lines, this has 8 hexagons. And you can see every combination there. So how does the logic machine work? Well, it works by having these cut out templates with different propositions on them, and you just put the template over the base template and it shows you what propositions are consistent with that premise. So here we have proposition A. Now what's A consistent with? Well, A on its own is consistent with A, of course. It's consistent with not B. It's consistent with C and not C, and it's also consistent with B. So it's consistent with A, it's consistent with not B, not C, it's also consistent with B and C. So if you can see on the base triangle through the template, through the upper triangle, the proposition that you're after, all of these propositions are going to be consistent with this one represented by the top triangle. You can switch this triangle around to B, so now we're testing to see which is consistent with B, and what is shown is, yeah, B of course is consistent with B, but so is A, so is not A, so is C, and so is not C. So that's basically how it works, and you can make these arguments rather more complicated. So as well as A, you could wonder what's consistent with A and a premise A hook B. So what's consistent with the A and A hook B? So hook here is if then, is the material conditional operator. So essentially we've made the argument modus ponens here. So we have A as a premise, if A then B is a premise, and we can see what's consistent with it. Well, what's consistent with A and A hook B is A, B of course, and C or not C. So this brings out an interesting feature of propositional logic, in this case the modus ponens. It seems like both C and not C are going to be consistent with the premises of modus ponens, right? So you could have the premises modus ponens A and if A then B, and the conclusion C, that would be a valid argument according to the logic machine. So would A, if A then B, and not C, right? Both of those are valid arguments, and that's a feature of propositional logic which you can see really simply, which is kind of really obvious, because there's no way for the premises to be true and the conclusion false, because there's no way for the premises to conflict with the conclusion, because the conclusion is just a totally separate propositional variable, whether it's C or not C. What you couldn't do is say we add another argument, another premise to this argument. So now we have the premises A. Let's have a look at the premises. Suppose we take the premises A, if A then B, and the premise not C. What's going to be consistent with that? Well, now we can see that the only conclusions consistent with those premises are A, B, and not C. Okay, so no, C is no longer consistent with the premises not C, if A then D and A. Of course, it doesn't matter what order you put the templates on the triangle. All that matters is what gap is left after the end, after you put them all together. So that's the basic way the logical machine works. You can add these premises together. So let's have a look at some other cases.